Hi, welcome to another episode of Science Made Simple. I'm Mr. Ryan and I'm a secondary science specialist here at the Pique Lab. In this video, I'll be analysing a past year exam question. I've also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. Let's take a look at this question together. Camphor is naturally obtained from a plant and has many medicinal uses. A brand of skin ointment is found to contain camphor together with other impurities such as iron, iron trioxide, and sodium chloride. Just taking a look at this ointment, what can you tell me about it? Is it an element, compound, or mixture? Since it contains more than one substance, this tells me that this is actually a mixture. Moving on, we are given a table, and in this table, we have a list of substances which are present inside this mixture. As well, we are given some liquids over here which can be used to attain some form of chemical reactions. However, let us take a look at what the question wants before we decide how we can use the table to answer this question. The question asks, which of the following is the best method to obtain pure camphor? Since we are trying to obtain pure camphor, this question is actually related to the topic on separation techniques. How then do we select the separation technique that we want to use? We need to ask ourselves, what is the unique property of camphor to select our method? Here, we need to rely on the table above to find out. To use this table, we need to go column by column to find out what is the unique property of camphor. First, let us highlight camphor in this table because this is the only row that we should be focusing on to figure out whether camphor has a unique property with each of these liquids. Looking at water, is camphor unique with water? Right, first, to understand what it means by unique, we need to take a look at what happens. Camphor will have no effect with water. This means that there will be no observable change when we put it with water. However, is this unique with water? No, if you take a look at the rest, is no effect with camphor, no effect with iron, and no effect with iron trioxide. This means that it is not a unique property for camphor with water. If I were to choose something unique with water, which one would it be? It would actually be sodium chloride, as it is the only one that dissolves in water. However, is this what we are trying to separate? No, right? This is not the one that we highlighted at the start. So I will probably not use water in my separation. Given that I have taught you to identify the unique properties, let's take a look at ethanol now and tell me whether camphor has a unique property here. Yes, actually, if you take a look at the table, you see that camphor is the only one that dissolves in ethanol and the rest of them show no effect. So now that we have identified that camphor has a unique property with ethanol, now we have to think about how to use ethanol for this separation. I'm going to draw it up here. So the first step is to dissolve with ethanol, right? After we add the ethanol and it has dissolved, what will we get? We will get a mixture with some liquid with some solid inside. What will be this liquid? This liquid will actually be our camphor solution. What about these solid particles here? These solid particles will be our remaining substances. Since we have a solid liquid mixture now, and the thing that we want is the solid or the liquid? Is the liquid, correct? The solution. How are we going to obtain this? We should filter. And to do filtration, we need a filter funnel with filter paper. At the end, there will be two outcomes. You will get the solid, which we call the residue, and the liquid, which we call the filtrate. So which one is camphor, the residue or the filtrate? Camphor will be the filtrate. How do we get pure dry camphor from the filtrate? We will need to do crystallization. So this is the three-step method that we will approach this way of obtaining camphor using ethanol. Dissolve, filter, and crystallize. Now let's take a look whether dilute nitric acid also gives us a possibility. Notice that there are three different outcomes here. No effect, reacts to give a solution, and dissolve. Given that there are three possible outcomes, how do we know then which one is unique? Take note, observation is what we are looking out for. The observation for the reaction to give a solution as well as this solution, both are in fact the same. When it reacts to give a solution, the solid now disappears. And this is the same when sodium chloride dissolves, which means that in fact we will only have two different observations. Since there is no effect of camphor with dilute nitric acid, this means that at the end of the day, camphor will remain as a solid. What about the rest? All of these will actually give me solutions. So since we see that there are only two possible observations here, is camphor having a unique property? It is, because it is the only one that will remain as a solid. So now how can we use dilute nitric acid to obtain camphor? If we take a look down here, there are a few steps, right? The first step is to add nitric acid. After we add nitric acid, we will obtain solution and solid, correct? The solution now is what? Iron 3 oxide, as well as sodium chloride. The solid that is left behind is now our camphor. Now how do we separate this? We said earlier on, to separate a solid liquid mixture, we will need to filter this, right? After we filter it, we will get back our same setup, the residue and the filtrate. Now, is the camphor the residue or the filtrate? Camphor is now the residue, okay? Over here. How do we now get a dry and pure sample of the camphor from the residue? We will need to rinse and dry. Okay, so now there are three main steps for the dilute nitric acid weight. Add dilute nitric acid, filter, and rinse and dry. Now let's take a look at the steps given to us in the options. Option number 1 says add ethanol, alright, this is okay. Filter, alright, this is what we said. And it says rinse and dry. Now notice that inside the question, when you talk about filtration, they do not directly tell us whether we are dealing with the residue or the filtrate. So when you say rinse and dry, we are actually talking about the residue, because that is the only thing we can rinse and dry, right? In the ethanol case, is the camphor the residue or the filtrate? We said earlier on that this is the filtrate over here, right? So do we rinse and dry the filtrate? No. So this is not the answer. Next, we see add dilute nitric acid, alright? Filter and crystallize. Crystallization here is for the residue or the filtrate? It is for the filtrate, right? Take a look at the bottom. Here we have written for the nitric acid case, are we looking at the residue or the filtrate? We are looking at the residue. So we should not be crystallizing it. Looking at option 3, it says add dilute nitric acid, filter and rinse and dry. This is exactly as what we have talked about at the bottom over here, right? So the answer here is actually option number 3. Let's take a look at why option 4 is not a better option or why it is wrong. Here we add water, alright, we add water, only sodium chloride dissolves. And then we filter it, and they say we add dilute nitric acid to the filtrate. What is the filtrate? For the filtration with water, we will get the filtrate, which is sodium chloride, because that is the only one that has dissolved. So since sodium chloride is the one that dissolved at the end of the day, are we going to be able to obtain camphor? No, because camphor is not inside the filtrate. So this is why option 4 is wrong. Thank you for watching, and I hope you have enjoyed this video. Found this video useful? Give us a thumbs up and check out more by clicking the links over here. You can also subscribe to our channel for more interesting videos. Until next time, stay curious inside and limitless outside. Bye!